Hello everybody. In this video, we are gonna be covering the bubblesort algorithm. It's pretty simple and important algorithm to understand because it really teaches you a lot and prepare you for more complicated algorithms. In this video, we are gonna dive into the bubblesort and explain it. The goal is to sort a list of numbers. We want to sort it in an ascending order. In other words, we want smaller numbers to come before the larger numbers. So, how does bubble sort work? Basically, we're gonna iterate through the array multiple times. And each time we iterate through it, we are gonna perform swaps to place numbers in their correct order. For example, here, let me. Uh, at this point, we start at 5 and check if these two numbers, 5 and 3, are in the correct order. Is the current number smaller than or equal to the next number? Let me put this question here. If they are sorted, we just move on and continue traversing the array and checking. But if they are not in the correct order, like this, in our case, 5 should come after 3, then we have to swap numbers in place. Swap and continue to next number. When we finish traversing the array bonds, we ask ourselves, did we perform any swaps or not? If yes, that means the array was not sorted. So we have to redo our entire iteration once more. If we didn't do any swaps, then the array was sorted and we are done. We can just return the array. One important thing is that bubble sort occurs in place, meaning whenever we swap any two numbers, we are doing it in place. Let's actually go through this flow on our example here. Let's start here at 5. We ask the question and something like this, for example. Okay, current number greater than equal the next number. So that's the reason why we have to swap. Let's do it. We are going to swap this 3, 5. We move the pointer 5 1. So swap. I'm going to change this and this. We move the pointer here. As you see here, 5 is smaller than 6. So we are going to continue and move our pointer without doing any swap. 6 and 2, okay, we have to swap. Let's swap this, 2, 6. Moving the pointer here. And again, 4, 6. Moving the pointer. As you remember the question after our first iteration, we have to check that did we do any swaps or not. Since we had a couple of swaps in our iteration, we are going to continue checking and iterating through this array again. So that's the second iteration. We start from here. We need to swap. We go here, 1, 3, move our pointer, not this one. Move our pointer here. 3 is less than equal to 5, so we are not going to do anything. We move the pointer 5, 2, we need to swap here. We move the pointer 5, 4, needs to be swapped. Pointer here, swap again. And final position here. So if you noticed, we have some kind of natural pattern here. One important thing is that what we have effectively done in our first iteration is we have kind of put the last number here, 6. 6 is in the final correct order, because at each point we are comparing the order. So naturally, whenever we get to the largest number in our array, we know it's gonna end up swapped all the way to the right. So let's continue. We can ask this question again and continue our iterating through this array again. And start here. 1 is less than 3. 3 is greater than 2. We swap it. 2, 3. We move the cursor or pointer here. 3, 4 is okay. And we are going to move this to next number. For 2, we need swap here. 2, 4. Okay. And again, you can see the pattern discussed. 4, 5, 6. They are in their kind of natural order. And we are going to ask this, did we do any swaps? And yes, we are going to go through the array again. Here. And this is our pointer. 1, 2, 3, okay. 3, 2, we need to swap this. 2, 3. And here we get this pattern again. Now, let's look at the space complexity analysis of this algorithm. In terms of space complexity, bubblesort is actually gonna run in constant time. It means it would be O of 1. I'm going to put this here. Since we didn't allocate any additional memory, that's constant. Now the time complexity is going to be O of n squared. So let me put this here too. And now we are kind of looping through the array multiple times, right? Looping the array until it is sorted. And where our n is the length of our input array, y of uh, for example, of n squared, because we are looping through the array multiple times and until it gets sorted. In the worst case scenario, or even average case scenario, we are gonna doing bunch of loops here. Uh, Best case scenario, for example, if we for example give this array as an example to our function, we would have the O of n, because at least we need to go through the array once and we check that, kind of traverse it once, and then ask ourselves, did we do or did we perform any swaps? Since we haven't, for example, we can't do any swapping here, we are done and we just return the array. All right, so we got our bubble sort defined here. It takes in an array of integers. The way I want to do that is by uh, implement it by test-driven development approach. It's a good practice. So first I'm going to create test here and say, for example, with a single element array. Int array, something like this. Expected result should be something like this. Bubble sort do sort array as an argument result, and we are going to use the assertions that assert array equal expected and result. Let's test this. Okay, let's do something to pass this test. I'm going to return the array and run the test again. That's good. Let me copy this and create another test with unsorted array 5, 4, 2, 1, 10, for example. 1, 2, 4, 5, 10. Cool. Now let's test it. Okay, now we are going to implement this. The way I like to implement is to keep track of whether or not the array is sorted in a Boolean variable is sorted. Set it to false because at the beginning we assume that the array is not sorted. And then we are going to have a while not it's sorted, do some stuff here. We're gonna do stuff, mean traverse with all the checks. We want to check the whole array. So tentatively, I'm going to say is sorted, let's set to true, and then jump to the for loop and say it starts from index 0 and goes array.length -1, because since we are comparing the current number with the next one, we don't need to go to the end of the array. And then we check if the array current number is greater than the array I plus 1 which is the next one, do something. Here, do swap the I index with the next one and the array. That's it. Before I implement this function, helper function, uh, the important thing is that when we found ourselves in the if statement here, it means we swap. So we have to change our flag is sorted to false to make it traverse again. Okay, I'm going to implement this. In temp equals to array first, and let me use this second, and second equals to temp. Okay, cool. Let's test. Okay, that's good. Now, if you remember, I mentioned that we have kind of pattern when we explained how the bubble sort is works, like this. We don't need to check through the entire loop and go through the entire array, uh, since at each loop the final number is gonna be in its final position. So what we can do here is we can say right before the while loop we can create counter, for example, set it to 0, and instead of going through all those arrays, we can say minus this counter, and the counter finally in the while loop, we want to increment it, and by every time it goes through this. And since we have the tests here, when we do some improvement, some optimization, we can always test our application easily. That's it. Thank you very much.